welcome to episode 11 of the Engine 9000 Debugger series. Today we're going to talk about viewing memory. So I've been trying to come up with a good solution to view memory in the Engine 9000 Debugger, and I hadn't really thought of a good concept for how to represent it until I saw an article by the author of Coppenheimer, who had checked out Engine 9000. And I wasn't aware of this project, but now I'm a massive fan of it. This is a absolutely beautiful piece of work. Coppenheimer is based on vAmega or vAmega Web. It's web-based, very similar to Engine 9000 in the fact that it's built on another emulator and provides a whole bunch of additional visualizations and some other features as well. This is a very cool project. You get an overview of RAM, and then you get a visualization of a section of RAM, and you can change the width of this visualizer such that you can get sort of accurate screen-based representations of what's on the screen. And you'll see it because Amega's planar, you'll see different planes. But long story short, when I saw this, I thought, yep, that's definitely the way that I want to do it. So I'm going to put a very similar system in Engine 9000. But yeah, hats off to Losso and the Coppenheimer project. That's a really awesome piece of work, and I'm going to use that absolutely going forward. I highly recommend checking it out. I'll put a link in the description. As well, vAmega. For those who haven't used vAmega or vAmega Web, I've been a fan of vAmega from day one, so I'm going to link that up as well. So yeah, please check out both of those projects. It's great to have so many options in Amiga emulation. Anyway, let's head over to Engine 9000 and we'll take it from there. So in Engine 9000, we're going to check out some Metro Siege stuff using the new RAM visualization, the RAM viewer. This works in a very similar way to the Coppenheimer viewer, and I've kept the amber colors as a bit of a tribute there. So a few differences. This overview column will show any RAM that's configured, and we've got a little legend to show you which RAM you're looking at. We can change the width to try and get alignment in the signal manually, or we can basically use the auto function, which is the equivalent of the Coppenheimer guessing function, to sort of automatically find where the bit plane pointers are being set and then try and work out the correct width to get signal alignment. We can scroll through the RAM using the overview column, which can be fun. But yeah, so what can we tell from this? Well, we can tell straight away this menu, for example, is basically 4-bit planes. So we can see 1-bit plane but double buffered. The interesting thing is you can see the technique that's being used to achieve this background scrolling. So the background is being scrolled using hardware scrolling, hence it sort of stays fixed in memory. And then the menu and the logo is being moved in front of that using the blitter. Give the illusion of it staying still in the background scrolling. Now, one feature that we have added to this is a combination of the memory viewer with the blitter visualizer. So we've already got tagged memory locations with blitz. So because of that, it's relatively straightforward to then highlight which RAM section is being affected by which blitz. Now, that does give another cool feature, is that we can now see off-screen blitz. So I might go back at some point and have a look at level 2 in Metro Siege and see if we can't see the level 2 subway platforms being rotated using the blitter. But for the time being, we're going to stick with level 1. Now, the thing that I really wanted to demonstrate today is loading. Now, it's very cool to see how memory is sort of filled out when we load stuff using this overview. So for example, Metro Siege, it loads data compressed in place at the end of the sort of allocated RAM section, and then it uses the decompression module then decompresses. So what you'll see is it'll put a chunk of data in RAM and then it'll go back and backfill it as it decompresses. So I find it really cool to watch. Anyway, let's see if we can see. So we can See there, yep, it loaded into RAM and then decompressed. Sometimes we'll see that it loads stuff and then goes back and does a bunch of calculations. That's this data section here is actually the RAM that that lays out all of the different animations and moves except for a player. So you can see this big empty space here. What's that for? Why isn't that RAM being used? Well, that's waiting for player 2 to join. If we were to load player 2, this RAM here would be filled in with player 2's animations and move sets. So, yep, we can just keep clicking the auto button until we get an aligned image, and once again we can see here that same configuration as before, 4-bit planes, double buffered, and if we single step we can see each character being cleared and then redrawn with the correct animation frame. So that's sort of cool to see double buffering. Now the last thing we can look at is if I can just quickly kill some enemies, is we can get a visualization of corkscrew scrolling. So corkscrew scrolling is a technique we use on the Amiga to achieve scrolling without having to move a whole bunch of pixels around. So what we basically do is we just essentially move the viewport in RAM, and we just fill out missing tiles as we scroll. So you will see here that you can pretty clearly see how it works just by watching the viewport move in RAM. And so once we get to the end of the additional RAM that's been allocated for that, then that's the end of this particular corkscrew. It uses a pretty simple corkscrew algorithm where you've got a fixed amount you can scroll with. That works fine for a beat 'em up where we don't need to wrap. It's different corkscrew techniques, different scrolling techniques that don't have that limitation, but as far as RAM efficiency goes and speed, this is a pretty good choice for Metro Siege. But yeah, cool to see in the new RAM visualizer. Yeah, so check it out if you get a chance, and let me know if you have any troubles. It should configure with all the different RAM types. If you've got fast RAM, slow RAM, I haven't really thought about what we might do with ROM, but it might be interesting to look inside ROM as well. But yeah, have fun.